Simplifying fractions. How can I simplify 10/25? Go ahead. 2/5, and how'd you get to 2/5? Divided each by 5, good. Okay. What about C? Let's do the numbers. What does 27/9 simplify to? So 27/9 is, go ahead, 3/1. Would it be okay if I just put 3? Yep, it's okay if I put it over 1, but I'll go ahead and leave that fraction bar there. I don't need the 1 necessarily. Okay, let's do the x's. So we have x to the 3rd over x to the 5th. What do I do with those exponents? We subtract them, yep. And where does it end up? On the bottom, why? Yeah, the larger exponent's on the bottom. So the x is gonna go on the bottom. And what's 5 minus 3? 2, bless you, okay. Good, and then we have y to the 5th over y to the 3rd. So where's that y gonna end up at? Top, and what's 5 minus 3? 2, so we have y squared up top with the 3. And then we have a lonely z. Where's that z gonna stay? On the bottom. Good, so we have 3y squared over x squared z. Okay, any questions with that? All right, multiplying. How do we multiply fractions? Right, we can multiply the numerators, multiply the denominators, and then simplify, right? Okay, and then, or we could do something else, and I'll talk about that in a second. What is 24 times 15? 360? Over 5 times 8? 40. So simplify, the zeros would cancel out, and what's 36 divided by 4? 9. Okay, so that is one way. What is another way I can do this? Okay. Yep. By both sides by 8, so 24 divided by 8 is 3, and 8 divided by 8 is 1. Yep, the 15 and the 5, which becomes what? 3/1. Good. And then we can multiply straight across. So 3 times 3 is 9. 1 times 1 is 1. So we get 9/1. Good. Now, I personally like simplifying first. Why? Because then I don't have to multiply 24 by 15. I don't like taking big numbers and multiplying. Now, it's not hard, but it takes more work, right? So I try to simplify first. Now, do I have to go diagonally? Could I go up and down? I could go up and down too, couldn't I? Yeah, but could I go across top and top? No, or bottom and bottom and simplify? No, they either have to be diagonally or up and down. You always have to simplify something from the numerator with something from the denominator. It doesn't matter where, but something from the numerator, something from the denominator, okay? So as I look at D, what is something I can simplify here?
14 and 7.
7, yep, good. I hear it here and there. 7 and 14 would be what? 2 and 1, right? And I kind of go that way. What else can be simplified? 12 and 8. And what can go into 12 and 8? 4. So this would be 3 and 2. Okay. So now let's go ahead and just deal with the numbers, and then I'll do the variables here in a second. What's 3 times 2? 6. And 2 times 1? 2. Now, I can simplify farther, couldn't I? What do you get, Liam? I could have simplified the 2 and the 2, which would have made 1/1. And we end up getting what? 3. Okay. And again, you could have done it where you multiply, you simplify diagonally and got 6/2, then simplified 6/2. Or as we heard here, the 2's also simplified and we did the 1/1. Okay. Now, the variables, we can go ahead and cross simplify if we want, or we can go ahead and just multiply them and then do our subtracting, okay? So either way doesn't sense. I'm gonna go ahead and multiply it. What's x squared or x cubed times x to the 4th? X to the What's x to the third times x to the fourth?
X to the 7th.
X to the 7th. Why is it the 7th and not the 12th? Because we add them, right? Then we have y on the top still. All right, let's do the bottom. What's x times x? X to the 2nd. Good. And then we have y to the 3rd, right? Now, can we go ahead and do our subtraction of my x's? Yes. So we have 3. Now, x to the 7th over x squared, where's the x going to remain? In the top. And what's 7 minus 2? 5. The y, where's it going to remain? The bottom. And 3 minus, what's the exponent with y? 1. So 3 minus 1 is 2. So we get 3x to the 5th over y to the 2nd. Okay. Now, we could have simplified here if we wanted to with the x's, but sometimes it gets a little crazy with changing the exponents and that. So sometimes I like to multiply, add those exponents, and then subtract them. Okay. All right. Any questions with that? Now, remember, the only way we can simplify fractions is if it's multiplication, right? Let me ask you, if I have something like this, 2/5 plus 5/10. Can I simplify the 5 and the 5? No. Can I simplify the 2 and the 10? No. Because of this plus sign, we cannot cross simplify. What's the only way to add fractions? Common denominator. And what is my common denominator? 10. So what did I get? 5. What did I do to 5 to get to 10? Multiply by 2. So 2 times 2 is 4. And 5/10 is already there. So what do we get? 9/10. Good. So again, we cannot cross simplify unless it's multiplication. Now, could I have simplified 5/10 if I wanted to? 5 over 10? Yes. 5 over 10, I could simplify to what? 1/2. And then I could have added it to the 2/5 if I wanted to. You still would have to get 10, wouldn't have? Yeah. Okay. All right. Any questions with that? Okay. So now what we're going to be doing here is we're taking what we just did in actually all of this, but now we're looking at plus and minus signs. So we're going to add in this factoring stuff, guys. Let's go ahead and put computers away so that you're paying attention, please. Okay. So the first thing we want to do, okay, we're going to look at rational expressions. So we're going to have like x plus 2 on top, or x squared plus 5x plus 10, something like that, okay? The first thing we want to do is we want to factor both the numerator and my denominator, okay? Do we know how to factor? Yes. First thing's always GCF, correct? And then if it's a binomial, we see if we have a difference of 2 squares. Our trinomial, this group likes to factor by grouping, okay? Polynomial, we group the first factor out the GCFs, okay? Then we're going to divide or simplify, okay? Now again, they can only be simplified if it's multiplication, right? Okay. And then the very end is we state the restrictions. I can't even spell restrictions. And I still spelled that wrong. That's all right. It says restrictions, but that's okay. I know that's all. Okay. The restrictions are, think about a fraction. What is the one number you can never have in the denominator? 0, right? 0. So we can never have 0 in the denominator. So if my denominator, let's say, if my denominator is like x plus 2, what can't x equal? What can't x equal? If my denominator is, let's just say, 1 over x plus 2. What can't x equal if my denominator would be 0? Negative 2. X could not equal negative 2. Because if x equaled negative 2, wouldn't my denominator be 0? Yes. Okay. All right. So we're going to simplify 3a plus 6 over 3a plus 3b. Okay. Now, we can't simplify 3a over 3a. That's not 1. Do you know why it's not 1? Because what do we have in between here? We have these addition signs. And can we cross simplify or anything when we have addition signs? No. So what I always tell people to do, if we see plus or minus, I like to group them together. They're married together. They have to stay together. Okay? We cannot, the only way we can cross those out is if it's the exact same thing in the denominator. Okay? So if I saw 3a plus 6, I could only simplify the denominator as if it was 3a plus 6. Okay? So first thing, let's go ahead and factor this. What can be factored out of my numerator? A 3. So my numerator would be 3 times what? A plus 2. Is everyone okay with that? Now, 3 I can simplify because now it's multiplication, couldn't I? A plus 2 I can simplify with something because it's multiplication with that 3. Okay? Over, what can be factored out of 3a plus 3b? 3, and what would I be left with? A plus b. Okay? You guys okay with that? Now, do we have anything that is multiplication here? Yes, I have 3 times and 3 times. So can I simplify the 3 over the 3? Yeah, what is 3 divided by 3? 1. Now, is a plus 2 over a plus b the same thing? No. So my simplified form is a plus 2 over a plus b. And again, I can't simplify the a's because of the plus signs. Okay? Now, what can't a equal? What can't a equal? Well, 0 plus b, wouldn't that give me b? So remember, if our denominator can't be 0, then a can't be negative b. Or b can't equal what? Negative a. Good. We set our denominator equal to 0 and solve. Now, because there's 2 letters, we had 2 restrictions. Okay? All right. Bless you. Did I sneeze? All right, let's look at C. All right, first thing. It's open. Okay. Oh, you're welcome. You know what lunch is? Thank you. Just so I know, don't I eat whatever I want. Sorry about that, guys. All right, so let's look at C here. Can I factor the numerator? Yeah, it's a binomial, right? Do we have a GCF of x squared minus 9? I do have a GCF? No, I don't. That's okay. Do we have a difference of 2 squares? Yes. So if we have a difference of 2 squares, remember I can do 1 plus and 1 minus. What's the square root of x squared? X. And what's the square root of 9? 3. Is everyone okay with that? Okay. Now, what do we notice about my denominator? It's already factored, isn't it? So can I factor that anymore? No. So I'm going to write 2x plus 1 times, can I go ahead and switch 3 plus x to be x plus 3? Yeah. All right. So is everyone okay with that? Now, because these 2 quantities are multiplication, am I allowed to simplify? Yes. Do we see anything the exact same in the numerator and in the denominator? X plus 3. So could I cross out x plus 3? Because what's x plus 3 divided by x plus 3? 1, right? Anything else? No, so I'm left with x minus 3 over 2x plus 1. So this would be my simplified value. Now, here's with our restrictions. We actually have 2 restrictions. Why do you think we have 2 restrictions in this one? Why do you think I'm going to have two restrictions? Right, there's multiplication, but also look at the very beginning. How many quantities did I have? How many variables did I have? I had two variables, so I have two restrictions, right? So what would be my first restriction? So x plus 3 would equal 0. So what can't x equal? -3. Why? Because -3 plus 3 would be 0. And what's 0 times anything? 0. That's why that can't be -3. And then the other one, we have that 2x plus 1 equals 0. So what can't x equal? Well, how do we solve for x? How do I move that 1 over? Subtract it, right? And then how do I get rid of that -2 or that +2? Divide it. So what can't x equal? -1. So if you notice, isn't finding the restrictions the exact same as when we solved by factoring? The only difference is now it's not x is equal to those, x can't equal those because it would make our denominator 0. Okay? All right. Any questions so far? Everyone at home, you guys doing okay? So let's go ahead and factor. Okay. Go ahead and factor my numerator. I'll give you a few seconds to factor my numerator. So A is not 1 anymore, right? So you got to think a little bit on this one. Okay. Give you a chance to think. So my A times C is -6, has to be 1. So what times what is -6 that adds to be 1? What times what is -6 that adds to be 1? Perfect. -2 and +3, right? So then I would normally go x minus 2, x plus 3, but what do I have to divide by? Oh, you guys do factor by grouping, right? I'm going to do divide by A here. But I would divide by A, which is 2, right? What's 2 divided by 2? 1. So I'm going to have x minus 1. Can I divide 3 by 2? Nope. So I pulled the 2 out in front and get 2x plus 3. Okay. If you guys want, I will show you how to do a guess and check for that later today. Okay. All right. Now, if we look at B, normally is it x, or the denominator, not B, but the denominator is always x squared plus bx plus c, right? So let's go ahead and reorder this for me. So isn't that the same thing as -x squared minus x plus 2? You guys okay with that? I put the x squared in the front because if you notice, we have x's in front here, right? Now, do we normally have a as being negative? No, so I'm going to factor out a -1 first. Okay, so if I factor out a -1, doesn't my x squared become positive? My x becomes positive and my 2 becomes negative. You guys okay with that? Okay. All right, now let's do my a times c. A times c is -2. That adds to be b, which is 1. So what times what is -2? That adds to be 1. -1 and a +2. Perfect. So we have x minus 1, x plus 2. And if I divide by a, isn't my a 1? And when I divide by 1, does anything change? No. Okay. So now we're factored. What do we notice that's the same in both my numerator and my denominator?
X minus 1.
Yeah, x minus 1. So could I cross those out? Yeah. And then I'm left with this 2x plus 3 over -1 times x plus 2. And again, I can't simplify these x's because they're grouped together with that plus sign, right? That 2x plus 3 and the x plus 2. So now what are my restrictions? X can't equal what and what? And again, there was x squared, so there's 2 of them, right? So what's my first thing x can't equal?
1.
1, yep. And what's my other one? -2. Okay. Why? Because x minus 1 equals 0, x plus 2 equals 0. So you would add the 1 over, getting a positive 1, subtract the 2 over, getting a -2. Okay. All right, go ahead and do D on your own here. Go ahead and factor this. And if you notice, the numerator is exactly like we did this denominator. So go ahead and factor out or rearrange it first. And I always like to put the a squared first in standard form for us. So always put it in standard form. Okay. So if you look at the numerator, did you guys factor out a -1 first? Yes, because we always want that a squared to be positive. So I'm going to factor out a -1. And if I factor out a -1, I'm left with a positive a squared, a positive 3a, and a -10. Okay. All right, let's go ahead and factor my numerator. So we have a -1 in the numerator. The nice thing, again, a is 1 here, right? When a is 1, we don't have to do the long method, right? So what times what is -10 that adds to be 3? -10 that adds to be 3. -5, +2, or +5, -2? +5, -2. Why? Because we have to add to be a +3. So our 5 has to be positive, right? Now, a squared minus 4. It's a difference of 2 squares, right? And how do we factor a difference of 2 squares? 1 plus and 1 minus. Square root of a squared is a. And what's the square root of 4? 2. Okay, good. Now, what do we notice that's the same? The a minus 2, so we can cross those out because a minus 2 divided by a minus 2 are 1. And I'm left with -1 times a plus 5 over a plus 2. What are my restrictions? A can't equal and a can't equal. What's my denominator? A plus 2 can't equal 0 and a minus 2 can't equal 0. So what do we get? 2 and -2. You could also put plus or minus 2, either way. Yeah, you went to the numerator. Any questions with simplifying so far? Huh? Oh, yeah, no, it's always your denominator. Okay. All right, example 2. Now we're going to solve for x. So we're actually solving the equation. So if we're solving for x, We need to have, if there's multiple x's, don't we need to have them on the same side and put everything else on the other side? Yeah. So right now we have ax on this side, which is great, but we have bx over here. So how would I move a positive bx to the other side of the equal sign? I would subtract it, yeah. So wouldn't I have ax minus bx? You guys okay with that? Now I need to move everything else to the other side. So how would I move this a squared over there? I would add a squared. So I have a positive a squared minus b squared. Is everyone okay with that? Put x's on the same side, everything else on the other side. Okay. Now, normally we would combine these x's, but are these x's like terms? No. But what do you notice about those? Isn't that a greatest common factor? Yeah. And if it's a greatest common factor, can't I factor the x out? Yeah. And if I factor my x out, what would I be left with? A minus b, yeah, because we're taking an x from each of these. Is everyone okay with that? Now, what do you guys notice? If you guys look at a squared minus b squared, what do you notice from that?
Two squares.
It's a difference of two squares, isn't it? So could I factor this one? Yeah. So we're going to make 1 plus and 1 minus. What's the square root of a squared? A. And what's the square root of b squared? B. Are you guys okay with that so far? Now, we need to solve for x. Bless you. Okay. This says x times a minus b, right? So do you remember how do we get this a minus b to the other side? Divide it, yeah. A minus b. Lincoln, put your phone away, please. Thank you. Okay. And the reason why I divide it, because isn't a minus b divided by a minus b 1? Or just x equals, what happens over here? It cancels out the a minus b. So what does x actually equal? Just a plus b. And because we're solving for x, guys, we don't need to talk about our restrictions. Okay, and there you go. All right, go ahead and do C on your own here. Go ahead and do C on your own. Right. So the x's are already on the same side, aren't they? Which is nice. Yeah. Yeah, you have your pass, right? Yeah. Perfect. Okay. So we have our x's on the same side. So can't I factor out my x here? Yep. So let's go ahead and factor it out. And then I'll have c plus d left over. What do you notice about c squared minus d squared? Difference of two squares, so I can factor that as what? 1 plus and 1 minus. And what do we get? Good. All right, solving for x, how do I get rid of the c plus d? Divide it. So the c plus d divided by c plus d will cancel to be 1. So I'm left with x. C plus d's, don't they cancel over here? And I'm left with c minus d. Awesome. Okay. All right. Any questions with that one so far? All right. What about, do you guys want to do C or D? I'll let you guys pick C or D. If you guys look at yours at paper, this ending ended up underneath. I made the font bigger so you guys could see it a little bit better, and then it moved it over and I didn't check it. Peter, too, just when you do leave, I will have the video and the notes posted up after we go from here. Depending on where we're at, I might stop a little bit earlier, so I'll change homework a little bit. Okay. Just check. All right, so let's look at D here. Okay, so we're solving for X, and obviously as we're solving for X, the nice thing is my X's are already on the same side, aren't they? So what can I do with that? I could just factor that out, right? Okay, so when I factor out that, so I'm going to factor out an X, and what am I left with? So 2C plus 3D. All right, now over here, if you notice, this is actually a trinomial, right? Do we know how to factor a trinomial? Yes, okay. But because we have an A, we have to do it a little bit the longer way, right? So let's do our A times C that adds to be B. So what is my A times C? 36, and we want to add to be what? 12, okay. So what times what is 36 that adds to be 12? 6 times 6 and 6 plus 6, right? Yeah. So when we look at this, okay, as we put it in our parentheses, I'm going to put it over here before I put it over there. Okay, we have C's in the front, so I'm going to put a C in the front. We have a D at the end. So when I add in my factors, I'm going to add a D with it. Okay, and then we still have to divide by my A. And what is my A? My A here, 4. And you guys might factor by grouping. If we want to go over factor by grouping, we can do that also here. Okay, what does 6 over 4 simplify to? 3 over 2, right? 3 over 2. So don't I just pull my 2 out in front of my C? Yep. So then if I pull my, don't I end up with 2C plus 3D? And don't I end up with 2C plus 3D, because weren't they the exact same? Yeah, okay. Now, how do I solve for X? How do I get rid of this 2C plus 3D? Don't I divide both sides? Yep, so I'm going to divide by 2C plus 3D on both sides. So they cancel here, and I'm left with X. Now, I have 2 of them in the numerator. Can I cross out both of them? Just one of them. Why? Because I only have 1 in the denominator, so I can only cross out 1. So X is going to equal 2C plus 3D. And there we go. All right. Okay.
Can you do that one by grouping?
Yep, that's what someone just asked too. All right, so when I looked at this, okay, I always start with that 4C squared in the front, right? And then I end up with a 9D squared at the end, right? And my factors were 6, so I'm going to have plus, and I always use the middle term, CD in the middle. CD. You okay with that? And you can't see that, so let me slide that over. I'm sorry. So I put the first term, the last term, and then I put my factors in the middle there, okay? What is my GCF between 4C squared and 6CD? 2C. Yep. So if I take out a 2C, aren't I left with 2C plus 3D? Yep. Okay. Then over here, from 6CD to 9D squared, what is my GCF? 3D, so plus 3D. And I'm left with 2C plus 3D. So again, these go together. So that was one of them. And then this is just listed again. So that's where we get the 2C plus 3D. And then we have the 2C plus 3D. Okay. Tori, did that help too?
Yeah.
Okay. All right. Any questions with 6.1? Do you see why factoring is important to know? Yes. Okay. Now we're going to multiply. Do we know how to multiply fractions? Yeah. Do we know how to multiply rational expressions where we have like the a squared plus b times something else? Yeah, we should. Okay. Do you guys know how to factor? Can we factor first? Yeah. The nice thing I like about this is because if it's all multiplication, can't we cross simplify? Yeah, we can cross simplify things that are the exact same. Whereas before we were just doing top and bottom, now we can go diagonally like we did with the multiplying fractions. Okay, and then once we're done with that, can we multiply straight across? Yeah. I think we can handle this. And then see where we're at. Okay. And I might shorten and then finish this next class for you so we don't do too much in one day. All right, so let's look at A. Okay, we have 6x over y cubed times y squared over 15. Can we cross simplify if we want? Yeah, we've already done a problem like this on our bell work, right? So what can go into 6 and 15? 3. So what would the 6 become? 2. The 15 becomes a 5. Now, with the variables, we can either just get them multiplied first, or we can cross simplify if you want. Do you guys want to cross simplify first with the variables? Yeah. Okay. Now I have 2 y's up top and I have 3 on the bottom. So how many can I get rid of? 2. And where would the last one be left over? Bottom. So remember, when we subtract the exponents, where does the last one stay? Where your larger exponent is, right? And now let's multiply straight across. What's 2 times x? 2x. And what's y times 5? 5y. And there you go. Okay. All right, go ahead and do D on your own, and then we'll get to B. Yeah. You can do the A's at the end if you want, after you multiply. Is that what you were asking? No, yeah, we should. I just didn't do it on there. Yeah, so y shouldn't equal 0 on this one. A lot of times they'll tell you when to put it, but that's okay. Yeah, they'll state in every direction, they'll state the restrictions. Okay. So since I did not, let me check. All right. So what can I simplify in D? Everything, so I could do the B's. What's B divided by B? 1, those cancel, 1 and 1. What about the 2 and the 8? 4 and 1, good. What about the A's? The A would just go on the bottom because 3 minus 2 is 1, right? And it stays on the bottom. So now what do we have? What's 1 times 4? 4. And 1 times A times 1? Okay, so it's just 4A. I didn't say state the restriction, so we don't need to in this. But good job. All right, let's look at B. We have a lot going on in B, don't we? Can we factor though? Yeah, we know how to factor. So let's go ahead and factor every single spot, okay? So the nice thing is all of these aren't my A's 1. So we kind of have a little shortcut there, right? So what times what is negative 12 that adds to be negative 1? What times what is negative 12 that adds to be negative 1? What times what is negative 12 that adds to be negative 1? Anyone? Yeah, negative 4 and positive 3. Good. So we have x minus 4 times x plus 3. In that denominator, what can I factor out of x squared minus 5x? What can I factor out of these two? X squared minus 5x and x. And if I factor out an x, what's left over? X minus 5. Can I simplify anything in this first parenthesis? No. All right, times. X squared minus 25, isn't that a difference of two squares? Yes. So I can do 1 plus and 1 minus. Square root of x squared is x. And the square root of 25? And then x plus 3, I can't factor x plus 3, can I? No. All right, now with this, do we see, because now it's a multiplication, we can cross simplify things, can't we? What do we see that's in the same in the top and the bottom that I can simplify?
X plus 3.
I see an x plus 3. Those become 1s. What else do we see? X minus 5s. Anything else? No, so we're going to go ahead and multiply straight across. I'm going to have x minus 4 times x plus 5 all over what? That's over x, right? And there you go. I am not going to make you have to FOIL out that top again. Okay, so you can leave it as x minus 4 times x plus 5 over x. Okay. All right, let's look at E here. Ooh. 10x to the 4th. There's nothing to factor, can I? Nope. So we leave it as 10x to the 4th. Can I factor anything out of 6x and 12? Yeah, what? 6, good. And if I take out a 6, I'm left with x minus 2, good. Times 4x, I can't factor, so I'm going to leave 4x in my denominator. But my numerator I can, can't I? The nice thing again, a is 1. So it's a shortcut. So what times what is negative 2 that adds to be negative 1? Negative 2 and 1. Good. So we have x minus 2 and x plus 1. Great. Put your phone away too, please. Thank you. So what can we simplify here? X minus 2s, yeah. Those are both 1s. Anything else? The 10 and the 4, because that's multiplication, isn't it? What can go into 10 and 4? 2, so this becomes a 5. 4 becomes a 2. Anything else? The x's, right? So I have 4 and 1 on the bottom. So when I subtract them, what do I get? 3, right? And I'm left in the numerator. Okay. And I don't think I see anything else. Do you guys? No, so let's go ahead. What's 5 times x cubed? 5x cubed. And then we have times x plus 1 over 6 times 1 times 2 times 1 is 12. And there you go. And now you're simplified and multiplied. We're going to just do these last two and then we'll be done and we'll finish this. And we only have one lesson on Thursday anyways, so we'll finish this. I'm going to change the assignment. So if you guys at home have already looked at the assignment, it's going to change a little bit. So give me a few minutes. Let's go ahead and do C and D here real quick.
Ms. Cochran,
Yes.
do we have to state the restrictions for these
No,
ones?
only when it says to state them.
Okay.
Okay. All right, let's look at C. Again, A's all 1 here, makes it a little bit easier, right? What times what is negative 21 that adds to be 4? What times what is negative 21 and adds to be a positive 4? 7 and negative 3, perfect. So we have x plus 7, x minus 3 over. All right, let's do our denominator. We have what times what is negative 16 that adds to be a negative 6? What times? -8 and +2. Good. So we have x minus 8, x plus 2. Is there anything I can simplify there? No. All right. Let's go to the next side. What times what is 15 that adds to be -8? -5 and a -3. Is that what you said, Michael? Okay. Good. So we have x minus 5, x minus 3. All right, and then the last one. What times what is 14 that adds to be 9? Two and 7. So we have +7 and +2. It doesn't matter your order. All right. So now, do we see anything on the top and bottom that we can cross out? Anything the same on the top and the bottom? Lincoln? X plus 7, yeah. Anything else? Can I cross? X minus 3 and x minus 3, are they one on top and one on bottom? Nope. It's okay. I did this on purpose because a lot of people, remember, we can only cross simplify if it's on the top and the bottom. So like these x plus 2s, they're both in the denominator. I can't cross simplify them, right? Because we're multiplying, we're not dividing those two. Same thing with the x. So there's nothing else I can simplify, can I? Nope. So my final answer, what's left on the numerator? X minus 3. Do you see how there's 2 of them? So would it be okay if I just put x minus 3 squared? Yeah. Times x minus 5 over, what's on the bottom? I see an x minus 8, and I see an x plus 2 how many times? Twice. So I'm going to put it as a squared. Do you have to? No, you can list them both out. I like using the square because it takes up less room, personally. Okay. Any questions on that? All right, and then our last one, and then I'll give you guys time to work for a little bit, okay? A squared minus x squared. How do you think I could factor a squared minus x squared?
Difference of 2 squares.
It is a difference of 2 squares, isn't it? It's a subtraction, and they're both perfect squares. So I could do 1 plus and 1 minus. What's the square root of a squared? A. And the square root of x squared? X. Good. My denominator is just a squared times. We have a on the numerator. What about 3x minus 3a? Oh, you guys can't even see that. Sorry. 3x minus 3a. I can factor out a 3. And if I factor out a 3, what am I left with? X minus a. Huh. What do we notice here? What? I'm sorry? The x plus a and the x minus a is the same? No. I can cross out these ones? Are they the exact same? Are they? Is my x is negative here. They're not the same, are they? No. So we had a question. Could we cross out this one and this one? Technically, no, because x in the numerator is negative and x in the denominator is positive, or vice versa, right? But if you notice, aren't they almost the exact same? Let me ask you, if I factor out a -3 here, what would happen here? So if I factored out a -3, what would happen? I would get a -x and a +a. Now, are they the same? Well, couldn't I rewrite this as a minus x? Yes. Now, are they the same? Yes. So if for some reason, if you notice, and that's where you have to be careful with subtraction signs. If you notice that these are almost the exact same, just opposite of where the x and the a are, factor out a negative number. And if you factor out a negative number, doesn't it end up being the exact same? Yeah. So now can I cross out the a minus x's? Yes. So the only difference is I'm going to have a -3 on the bottom instead of a +3. Okay. Now, what about these A's? Can I cross out these A's? Yeah. How many A's are going to be left over? 1 on the bottom, right? So now in the numerator, aren't I left with just A plus X? And in the denominator, I have A times -3, which is just -3A. Why can't I simplify these A's? They're not the same because that's A plus X. That's grouped together. Remember, this is the same thing back in the day when we talked about A over -3A plus X over -3A, remember? So you can't simplify them together. You could if we did them individually, but we're not worrying about that right now, okay? All right, any questions with this? All right, we are going to finish this lesson on Thursday. So let's kind of go through what your homework is tonight, because obviously it's changing a little bit, and I'll fix it in Canvas for you.